Hi everyone, welcome to the first day of the Climate Match Academy course, Computational Tools for Climate Science. My name is Sloan Gerlich, and I'm a visiting assistant professor at Brown University in Providence, Rhode Island in the United States. I'll be introducing the videos for the tutorials today. During this first day of the course, we'll go through an overview of the climate system, including different parts of the climate system, forcings and mechanisms that drive changes in the climate system, and the importance of understanding past, present, and future climate variability. Climate is the weather condition occurring in an area over a long period of time. An Earth's climate is controlled by many forcings, feedbacks, and interactions between various processes and systems. And some of the main systems in Earth's climate include the atmosphere, the biosphere, the terrestrial systems, the cryosphere, and the ocean. There are multiple climate forcings that affect these climate systems and result in changes in climate. Some of the main long-term natural forcings are solar radiation, orbital cycles, and the carbon cycle. Additionally, anthropogenic forcings are also influencing the climate system and occur on much shorter and rapid timescales. These forcings, among other forcings, result in changes in different components of the climate system, which we can understand by looking at data of different climate variables. And some types of climate data that we can look at to assess changes in the climate system include temperature, precipitation, atmospheric composition, and changes in vegetation. On long timescales throughout Earth's history, there have been long-term changes in Earth's climate in response to variations in natural climate forcings, such as orbital forcings and the long-term carbon cycle. However, today, changes in the climate system are occurring at a much faster rate than the past in response to anthropogenic causes in greenhouse gas emissions. This figure is from the IPCC report and shows changes in multiple climate variables since 1850, and this really highlights the impact of anthropogenic forcings on the climate system. For example, over this time, there has been an increase in atmospheric CO2 concentration, increased variability in precipitation, increased glacial mass loss, a warming of global surface temperature, a global sea level rise, and an increase in the ocean heat content. And these are just a few examples of ways in which anthropogenic forcings have influenced recent climate. Other examples include sea ice loss at the polar regions and terrestrial habitat loss due to deforestation and land use. During the remaining videos today, we'll learn more about different forcings and processes of the climate system and how they vary on different timescales. And throughout these tutorials, we'll learn how to use a Python package called Xray, which is specifically designed to analyze large climate data sets. Xray is an open source project and Python package that makes working with labeled multidimensional arrays simple and efficient. Xray introduces labels in the form of dimensions, coordinates, and attributes on top of raw data array similar to those produced in NumPy. Xray includes a large number of functions for advanced analytics and visualization of these data structures. Throughout the tutorials today, we'll learn the basics of Xray and apply some of these tools to the climate data sets to further explore the climate system concepts that we discussed in the videos. In this tutorial, we'll learn how to create data arrays and data sets in Xray. And both of these objects are used to represent and manipulate spatial data. The data array is one of the basic building blocks of Xray. In a data array, coordinate names and values are stored with the data, making it simpler to slice and index the data. Along with the data arrays, the other key object type in Xray is the data set. This is a dictionary-like container that holds one or more data arrays and can share coordinates. To understand the global climate systems, its forcings and variation, we need to assess large global data sets. And these large data sets tend to have multiple dimensions and variables. Therefore, using Xray is incredibly useful. In this tutorial, we'll explore data array and data sets, which allow us to organize these large climate data sets.